Now that the game has some pretty basic features, we're going to add the ability to save the game and load from the saved game file. This will make it so someone can actually play the game. Currently, we save our game data in XML files, but I'm switching to JSON for this. That's JSON if you haven't seen it. That stands for JavaScript Object Notation, and it's just a different way of storing data files. I'll show you an example of it so you'll see that it's pretty similar to XML. The reason I switched is because you're more likely to see JSON nowadays than XML, especially if you write any code that uses REST APIs. That usually expects JSON data in and usually responds with JSON data. So the first thing we're going to do is open up the solution, and we're going to create a new class called SaveGameService. It's going to be in our engine project in the services subdirectory. In order to work with JSON, I decided to include a NuGet package. If you haven't used a NuGet package before, it's basically a third-party library, some code that someone else wrote that you can include in your project. But it's managed through NuGet, which is a service where you can download some of these libraries, and you can also use them to manage them. As new versions of the libraries come out, you can automatically upgrade your program with it. The way to access the NuGet Manager is to go to Solution Explorer, right-click on Solution, and select Manage NuGet Packages for Solution. If you select the Browse option on the menu, that will let you search for a NuGet package. You can type in the name of the package you want, and it will show you all of the NuGet packages that have that string in the name. In this case, we want to install Newtonsoft.Json. So you just left-click on that, and over on the right, you'll see a list of all your projects in the solution. You can decide which project you want to add the NuGet package to. In this case, I selected the engine project to add it to. For the version, I selected the latest stable version, and then there's an install button over here that you can click to add the package to your code. I've already installed it, so I just have the uninstall button available. But for your first time, you'll see that you'll have the install button available. Now once the install is completed, now we have the ability to use the Newtonsoft.Json functions in our project. So let's close this and go to our SaveGameService class. We'll start by taking a look at the using directives on lines 1 through 7. The unusual ones here that we're adding for the first time are system.io, which lets us read and write files. And on lines 6 and 7, we have Newtonsoft.Json and Newtonsoft.Json.link. This will let us use the classes and functions from the Newtonsoft NuGet package. On line 11, this is a static class. We're just going to use this as kind of a service. And on line 13, we have the save game file name as a constant. In the future, you may want to change this so you can have multiple save games, but for now, we're just going to have one save game. At the end of the game, when you shut it down, we'll save to that file, and when you start the program up, we'll see if that file exists. If it does, we'll read it in and load the game from the data in there. Lines 15 through 19 are a pretty simple save function. What we're going to do is pass in the game session object because that has the current player, their current location, information like that. Then we're going to do file, write all text. This is from system.io, which this will create a file. The save game file name, the first parameter of the write all text function. And then the data that we want to put in the file is this JSON serialize object game session, and we're using formatting indented. So what this will do is it will take the game session object, it's going to serialize that to JSON, this function returns a string, and that string will be written into the save game file. Now to give you an idea of what a serialized game session object looks like, here's one that I have from a game that I've been testing with. Notice we have curly braces here, opening and closing curly braces, whereas in XML we would have the opening and closing nodes with the lesser than and greater than in the name of the node. This is one thing that keeps JSON a little bit smaller. Our closing node is just a closing curly brace, so that saves a little bit of space. And then all of the properties on the game session object, since that's what we serialized, are listed here. We have a version property, which is a new one I'll show you that later. And the value of it is this, 0.1.000. We have a current world property in game session, which right now is empty, it's null. We have a current player object in game session, which is all this data down here. So let's look at the current player property, which is a player object. The player object has a character class property, which is fighter in this case. The player has an experience points property, which is 5. We have a list of quests, and the list is signified by the open bracket and the close bracket. In this case, we only have one quest in there, so our quest object, or our player quest object, actually is inside the curly braces. And then we have its properties, the ID of the quest, the name, the description, items to complete, the reward items, all that. We also have a recipes property on the player, which is a list of all the recipes the player knows, which in this case is just the one recipe for the granola bar, but we see the granola bar ID, the name, the ingredients, and these have an item ID, a quantity, and a quantity item description. Then we have our output items, which is another list with just the one item. So it's very similar to XML. If you can read XML, you'll probably pick up JSON pretty quickly. The structure is very similar. It's just something you're going to see a lot more often nowadays, especially with mobile apps, because they want to send as little data across as possible, and they don't want to have those closing tags and all the extra baggage that comes along with an XML file. Now let's go back to the Save Game Engine class. Our next function is load last save or create new. So this function is going to load the data from the last saved game, or if it can't, it's going to just create a new game session object and return that. So the first thing it does is it checks if the file does not exist, the save game file, then it's going to just instantiate a new game session object with the default values and return that. If it does exist, it's going to read all of the text from the file, all of that JSON we just looked at, and it's going to load that into the jobject.parse function. So this will parse all of this JSON and convert it from JSON into a JObject, which is something we can reference a little bit easier. Then on line 34, we're going to create a new player with that JObject data. I'll get to that function in a second. Just a couple of the other lines we have here on line 36 and 37, we're going to look at the game session's current location X coordinate and Y coordinate. So here we're referencing the data object, that JSON JObject that we just created. And we have this bracket, name of game session current location, and then a bracket, name of location.x coordinate. Referencing something with these dual sets of brackets is what you'd see in a multi-dimensional array. And that's basically what this JSON represents. It's an array of keys and values. So what we want to do here is go to our data object and find the element that has a name of current location, and then from there we want to find its child property of X coordinate. So if we go to our JSON file, we'll look for current location, which is right here. And then we're going to look for the X coordinate property off of that, which is right here, and that's -1. And the Y coordinate is 0. So the last time I played the game and exited, the saved game file was created, and the location I was at had an x coordinate of -1 and a y coordinate of 0. And all this JSON code is going to say, look at the parsed J object and find current location coordinate, convert it to integer, and that's our x value. And that's how we're going to read everything out of the JSON file. We're going to get it by these keys, and then we'll get the value. And I've got a catch here where if there's an exception, if we had a problem parsing this, then we're going to just return a new game session. We'll probably want to change that in the future to throw an error and let the user know there was a problem, but for now, we'll assume things go pretty well. So let's look at our createPlayer function. We're passing in that J object with all of our JSON data. And the first thing we're going to do on line 52 is call this file version function and pass in the data. Go down here. On line 151 is that function, and what we're doing is looking at the data, finding the version key, converting that to a string, and then we're going to return it. So if we look at the JSON, here's our version key. We're going to get this value and return that as a string. You might have noticed that the version is a new property. That's because we're serializing the game session object. And over time, we're going to change the game session object, or the current player object. We're going to add some values to that. We need to make sure that if someone plays the game and it's version 0.1.000 and they save their game, and we give them a new updated version that's expecting 0.2, we need to make sure we're parsing it correctly for the format. So that's what this file version is going to be. Now that we're doing this, anytime we make a change to the game session structure or the player structure, the properties that it has, or any of their child properties, we're going to need to create a new version of the parser. Let's go look at the player parser. So we're creating the player. We instantiate a new player object with no values. If the file version is 0.1.000, which they all should be at this point, we're going to say player equals a new player, and this time we're going to pass in values in the constructor for the name, for the character class, for their experience points, maximum hit points, current hit points, dexterity, and gold. These are all the values that the player constructor needs, and this code parses it from the J object and passes that in as a parameter. If you notice, we're using name of for all these property names. That's because I could have done something like quote current player and just pass that in. But if I do that, there's a good chance I'm going to make a typo. Maybe I type an uppercase U, and that's going to not match with the current player key there. So in all these cases, I use the name of to get the name of the property. So that way I know it's going to match 100% with whatever was written. Now once we create this new player object, we're going to populate the player inventory, we're going to populate their quests, and we're going to populate their recipes. And we're going to do that with these three small functions where we pass in the J object data and the player object, and then just loop through whatever we see in the JSON file for their quest list, their recipe list, and their inventory items. Here we've got the populate player inventory. Again, we're going to check the file version just to be safe on each one of these functions. And we're going to say for each item token in J array of these three values, the current player inventory items. So what this is going to do is we're going to look at the data. We're going to look at current player inventory items, which if we go here, inventory items, and we see this is a list. So this is being converted, or it's being cast to a J array, so we can loop through it. And each item in here is going to be an item token, a J token. So it's just going to be an array of these properties with these values. Then we go in here, inside our loop, we say, let's get the item ID. We're going to look at the item type ID property of the item token, which is going to be, here's our item token, here's what's in our item token. And we're going to look at the item type ID, get its value, and convert it to an integer. And then that's going to be our item ID. Then we call player, add item to inventory, and we're going to say item factory, create game item, item ID. This part here will take the item ID that we found, that 1001 value, go to the item factory, create the pointy stick, and add that to the player's inventory. And since this is a for each, we're just going to loop through each of the game items in the JSON, get the ID, and add that to the player's inventory. The next two functions, the populate player quests and populate player recipes, are basically the same thing. We're going to go for the current player quests. We're going to find those in the JSON. There's our list, and we're going to get each one of those, loop through them, call the quest factory to get the quest. We'll create a new quest status object, which is what we actually store in the player. And we're going to add in the quest that we just found through the factory. And then we're going to set the quest status is completed to the quest tokens is completed key value. So that's going to be this is completed and false. And we convert it to a Boolean because that's what the property type is. Once we have this quest status, we can add it to the player's quest, and that populates all the player's quests. Same type of thing for the recipes. We're going to look at the current player, look at their recipes list, create an array off of that, get each JSON recipe token, find the ID, call the recipe factory to get the recipe, and give the recipe to the player. Since this is new, you might want to put some breakpoints in here as you're running it. Well, maybe on the for eaches, and maybe up here on the player, so you can see what's actually being populated and what's happening, what you're getting in these item tokens and quest token values. And watch the code as it parses the data and actually creates the player object off of that. So then after this player has been populated, we've got our player up here in our main function. We've populated it with the data. We have the X and Y coordinates. We're going to return a new game session, passing in the player and the X and Y coordinates. This is a new constructor on the game session class that we'll see in a minute. Now that we have our save game and our load game functions written, we can go on to the rest of the changes, which fortunately are a whole lot easier than this. Just a few small changes in 3 classes and we're ready to go. The first class we'll change is the game session class. I did make one minor change here of the current battle backing variable. It used to be on line 12, I put it down here on line 16 with the rest of the backing variables. Not really important, but I just think it looks a little cleaner. Now for the real changes, on line 20 we've added this new public string property called version, and it's a get only property that returns this hard-coded value. And if you notice, this 0.1.000 is the same version we were looking for in the save and load game parser. So now when the save game service saves the game, as part of its serialization, it's going to say we have a version property and it has a value of this, so we're going to save that into the JSON file. It's get only because we are only going to read it. In the save game service, when we load from a file, we don't take the version number and set it in the game session object. This way, if we change the game session object and we create a version 0.2.000, what will happen is the first time someone opens up the game with an old save game, it's going to create what it can, but the next time the game gets saved, it will get saved with 0.2.000. So then the time after that when you load it, we'll have to have the parsers for 0.2.000 in place. The other thing we had to do was add a new constructor, one that takes in a player and starting location coordinates. That's down on lines 143 through 148. So we see here the public game session with the parameters player, x coordinate, y coordinate, and this creates the world, sets that in the current world property, and sets the passed in player to the current player property, and for the current location, it's going to find the location at x and y. In the old game session constructor, which we use if we don't have a save game, we do the create the world and set it to the current world, and we manually create this new player object with some default values, and we set their current location to the location at 0 to 0. This new one just takes in the player we created from the saved game data and gets the x and y coordinates from the saved game data. Next we'll go to the main window.xaml, and we only need to make one change here. At the very top in the window attributes, we need to add closing equals main window underscore on closing. So this way when the window is closed, for the closing event we want to run this new function, main window on closing. And in this function we're going to save the game data when the player exits the application. So when this window is being closed, call the function, which if we look in our main window.xaml.cs, down here on line 125 through 128, here's the function, and all it does is call saveGameService.save and passes in the underscore game session, which is the variable we're using to store the game session object for this window. So that's how the game gets saved. The player just exits out, this function runs, and it automatically gets saved. Now to have this function, this sends a cancel event args parameter. So we need to go up to our using parameters and add in using system.componentModel, because that component model namespace is where the cancel event args is. If we don't add that, we're not going to recognize it. And the final change we need to make is on line 18, we're going to have private read-only game session underscore game session. I think before we had this equals new game session. We're not going to do that because instead in the main window constructor we're going to have on line 30 game set underscore game session equals save game service load last save or create new. So now when the player starts the game, main window gets instantiated. We'll call the save game service load last save or create new. If a save file exists, we'll parse it, return a game session object, and store that in this backing variable that becomes the Windows data context. Or if the save game file does not exist, we'll just create a new one, pass that in there with the default values, and set that to the data context. So let's take a look at how this runs. But before we do that, let's look at the last save game data I have. So we see here the current player has 5 experience points, a dexterity of 15, and 1,000,003 gold. If we run the game, we see that the player has 5 experience points, 15 dexterity, and 1,000,003 gold. And the last location I was at was the trading shop. So let's go east to the fountain, exit out of the game, and go back and look at the save game file. We notice I've got a refresh notice here because my current location has changed from -1, 0 to 0, 0. And let's do a little cheating here. Let's give myself 2,000,003 gold. And just save that. Run the game again. And now we see I've got 2,000,003 gold. So in the future we might want to do some encryption on that JSON file so that the player can't just modify things to give themselves 18 dexterity and 1,000,000 hit points and 1,000,000,000 gold. But for now we'll leave it as just standard JSON while we're working with it. But the important thing is now we have the ability to save and load the game file, which makes this a lot more playable as a game. If you've been modifying your own locations and monsters and game items and all that, I think now you have something that you can actually show off to some of your friends. But we do have to remember, if we change game session, current player, or any of current player's child properties, we're going to need to do a new parser for it. And we're probably going to want to write some unit tests and store versions of the different parsers so that we can always run these and make sure that we don't destroy the program. You don't want to put out a new version of the game and then your players have to start over from the beginning, especially if they've been playing for a while. That's just going to frustrate the players. As always, if you're watching on YouTube, in the description below the video, I'll have links to the support page with all the source code, the Discord channel if you have any questions, and the GitHub repository if you want to get the source code from there. If you have any questions, please leave it below the video or go to the support page and leave your question there, and I'll try to get back to you as soon as possible.